All right, these are the solutions to the 4-word problems that I gave you to study for your test for Monday, November 11th. If we look at the first one there, $4.40 per pencil, $7.20 per pen. Pete bought M number of pens, so M equals pens. He also bought 5 fewer pencils than pens, so M minus 5 would equal pencils. Okay, we can't have we don't want two variables if we can avoid it, and we can avoid it. So M is pens, so M minus 5 would be pencils because we have 5 fewer pencils than pens. So they want to know an algebraic expression for the total amount that she spent. So pens cost $7.20, so we just write that as 7.2 times M, number of pens, plus pencils cost $4.40, or just 4.4 times M minus 5, the cost, or how many pencils that we've got. Now we see that we have two m's in here, so we're going to have like terms we can take care of. So 7.2m plus, and then we distribute this out, distributive property, and we get 4.4m minus 22. And then we add our like terms, 7.2m plus 4.4m is 11.6m minus 22. And we can't add those or subtract those two numbers because they are not like terms. The 11.6 has an M attached, the 22 does not, so they're not like terms. Now what you can do is you could put all of this in parentheses, and then you could write dollars after it to label it. So there's your answer to the first one. The second one, 16 packets of G almonds. Again, most of the time when you see that word of, that's going to mean multiply. So 16 packets of G almonds. So 16 of G, meaning 16 times G. So 16G. 4 packets of H walnuts. 4H, 4 packets of H walnuts. Of the total packets of nuts, 4 were given away. So given away means we're subtracting, and you're subtracting 4. Now we don't know if those are 4 packets of walnuts or 4 packets of almonds. We just know there's 4 packets given away. We don't know if it was 2 and 2, 3 and 1, what it might be. But we have our total number, so we're adding them together. Our almonds plus our walnuts minus 4 packets. Okay. And then on the test, it's going to ask you to then take your answer and factor it. So if we factored it, your greatest common factor would be 4. So 4 on the outside, and then 4G plus H minus 1. So that if we did the distributive property, we would get that answer there. Okay, 4 times 4G is 16G, 4 times H is 4H, 4 times 1 is 4, minus 4. All right. Third problem, ratio of 5 to 8. So Doug to Donna is in the ratio of 5 to 8. So it says how many pairs does Donna have in terms of n? So if it's 5 to 8, then their total in this scenario here would be 13. So Donna would have 8 of the 13 if we're in the ratio of 5 to 8. So 8 over 13 n. Then it says if n is 26, how many pairs does Donna have? So 8, 13, it tells you n is 26, so you replace n with 26. This means to multiply. 8 13ths times the 26 gives us 16. So Donna has 16 pairs. Then it asks for Doug. Well, if it's in the ratio of 5 to 8, then Doug would have 5 of the 13 times n, which is, they're telling us 26. So 5 13ths times 26 would give us 10, and that would be Doug. And as you can see, if we took 10 to 16, 10 to 16 would simplify to 5 to 8. And the last one, probably the most difficult problem there. 40% of the girls left the school assembly. The ratio of boys to girls became 1 to 4. If there were W girls when the assembly started, what was the total number of boys and girls when the assembly started? So we know that we need to ultimately add all of the boys and all of the girls together to figure out how many there were total. And then they give us some information in here to sort through. So first is our ratio of 1 to 4. So this is, and it always helps to write everything out, label things, put your thoughts to paper. So this is after 40% of the girls left. That was the ratio after 40% of the girls left. Okay, now before 40% left, that number of boys would still be 1. So it's 1 to something. We've got to figure out what that something is. Okay, so 1 to 4 after they left, and 1 to what before they had left. Now, if 40% left, that meant 60% were still there. 60% were still there. So here's what we have to kind of figure out. You kind of make up a variable for the number of girls that were there before, at the very beginning, before anybody left. And I'm going to just say X. And we'll throw it out later and you'll see what I mean. So X represents girls at the start. Girls at the start was X. Okay? 40% of those girls left, which means 60% were still there. 60%. So 60% of X would mean 0.6X. To find 60% of something, you would multiply it by 0.6 or 3/5, however you want to work it out. So 0.6 times X, and when we found 60% of X, the result was 4. Again, we're just using our ratio after all the girls left was 1 to 4. Okay, so for all we know, there were 5 people in there total after the girls left, and 4 of them were girls. So we now get the X by itself. Remember, X is how many girls were there at the very beginning. So to get X by itself, it's being multiplied by 0.6. So you divide both sides by 0.6. Those cancel, and X would equal 4 over 0.6. And if you do that division, 4 divided by 0.6, you get 6 and 2/3. 6 and 2/3. So we know that if it was 1 to 4 after, that it was 1 to 6 and 2/3 before. So before any girls left, it was for every one boy, there were 6 and 2/3 girls. Now, we obviously know that we can't have 2/3 of a girl there. We want that to be a whole number. So you have to figure out, what can I multiply 6 and 2/3 by to get it to be a whole number? Well, if you multiply by 3, that will happen. So if we do 6 and 2/3 times 3, you will get 20, the whole number 20. And if we multiply the 6 and 2/3 times 3, then we have to multiply the 1 times 3, and that would give us 3 to 20. So before any girls left, the ratio of boys to girls was 3 to 20. Okay? So we've got quite a bit of information there that we need to then write our algebraic expression for the total number that were there. Well, we know that there were W numbers of girls there. Okay, and the problem, it says W girls when the assembly started. So W, we know that W is how many girls were there when it first started. And we want to add to that the number of boys. So the number of boys was 3/20 of the number of girls, because 3 to 20. So if we do 3/20 W, that it represents how many boys were there at the very start. 3 for every 20 were boys, so 3/20 times the number of girls. So now we can add these two like terms together. Okay, we have a W and a W. So this represents 1 W, but we have fractions here. So we could also use 20, could also use 20 over 20, which again, 20 over 20 is 1 whole. So it's the same as 1 W. And we can add 20 over 20 plus 3 over 20 would give you 23 over 20 W. You could also have 1 and 3/20 W. Generally, we're just leaving these in proper fraction though. All right, and then don't forget about the last one. I mentioned there's a perimeter problem on the test, just like question number 2 on page 183.